program become a lighthouse. It does not just guide with answers but inspires with presence and wisdom drawn from experience. Through this program, we are in connecting students with renowned scientists, educators, and professionals will serve as beacons of inspiration and support, where it is research, advice, career direction, or life skills. Our mentors will be there to nurture minds and ignite dreams. We are deeply honored to have Dr. S.K. Varshney sir, a dynamic in science diplomacy and global research collaboration, inaugurate this program today. His journey is a testimony to what visionary leadership and dedication can achieve in science and society. To every student joining this program, remember this is your moment, a moment to ask, to learn, to grow, seek mentorship not just to find answers, but to discover better questions. Let your curiosity drive you, let your resilience shape you, and let your mentors empower you. To the mentors, thank you for coming forward to invest your time and energy into nurturing talent. You are planting seeds of excellence that will one day grow into forest of discovery and innovation. Let this program be a launch pad of our possibilities, a bridge between potential and performance, and a movement that shapes the scientific future of our nation. With that, I once again welcome you all to this historic beginning together. Let us build a legacy of learning, leadership, and limitless growth. Jai Hind, Jai Vigyan. Over to you, Raman. Thank you so much.
Thank you, Sanjay sir. With an illustrious career spanning over 3 decades, Dr. S.K. Varshney stands as one of the India's most respected science faculties and international science diplomats. A former advisor international at the Department of Science and Technology, Government of India, Dr. Varshney has been a driving force behind India's strategic global scientific collaborations from Russia to Canada and beyond. He has served with distinction as counselors at the Embassy of India in Moscow and played a vital role in nurturing India's bilateral and multilateral partnerships in science and technology. As a professor, uh, editor of PINSA and a key member on several academic and research councils, including HS Gore University, JSS Science and Technology University, and IC Impacts Canada. His insights continue to shape science policies and research ecosystems worldwide. A scholar at the heart and with academic roots from Delhi University, Aligarh Muslim University, and MIT University, Dr. Varshney combines profound scientific knowledge in earth science with unmatched experience in global science governance. Even today, as a freelance professional advisor, he continues to mentor, strategize, and inspire future leaders in science. Let us welcome a remarkable thought leader, a passionate promoter of international scientific collaborations, and an eternal student of science, Dr. S.K. Varshney. Sir, to you.
Thank you, Raman, and namaskar to everyone. Thank you, Sanjay, for inviting me to this platform. And I welcome you all on this very important platform. And just would like to share with you that what could be your journey to become a professional in world of physics. Well, physics, if we say in common man language, it is a science which connects matter, energy, and fundamental forces of nature. And it covers everything on Earth, from subatomic particles to largest galaxies. So if you see, you will find that physics is involved in our day-to-day functioning, and so many things which we are exposed to are governed by the laws of physics. Of course, you will learn it when you read it more, but question is that you would try to learn so many things during this journey, So it may include electromagnetism, thermodynamics, optics, mechanics, at atomic and nuclear stations level, also geophysics. So there are a number of things you may learn, but the time has come. It's not only the learning in science, which is important, but the more important is the application. I'm sorry, it should have come a little later. I'll come back to this. So you should have learned more about the application. So I'm just giving you two or three suggestions. There could be many more applications. So it's not the only list which you should worry about. So for example, in the field of aerospace, now we are using astronomical observations. Our Chandrayaan has landed on the surface of Moon. We are having a Spitzer space telescope so that we could see various universe through infrared wavelength. So a lot of things are happening. Even imaging, if you see X-rays or ultrasound or thermography, several kind of infrared cameras or MRIs, they are being used. So all of them are based on principle of physics. Even the communications, communication happens in several ways. Satellite communication, radio astronomical communication, optical fiber communication. So these days, we feel communication is too easy, like we are used to mobile and other things. But imagine people how we have grown up, and this is all where physics has contributed, and the mechanics. You know, automobile engineering, civil engineering, robotics, lot of new development is happening. But this is not these are just suggestions. But then there are a lot of new excitement in physics, a lot of new challenges are coming, and we need to know more and more about these challenges, like what is quantum sciences, how to create quantum hardware, quantum communication, quantum. We need to go much beyond artificial intelligence. We need to do operation at much faster speed. We need to understand about the universe. So a lot of dark matter and dark energy is there, nature of time, new functional materials for specific purposes, air turbulence, superconductivity. So there are a lot of challenges in physics. So what I would try to say, physics has got a lot of things, but question is who are the researchers? Dr. Sanjay Singh in his remark also mentioned about these things, that now since you have graduated, now you're going for the master classes or for doctoral classes, you need to understand who are the researchers. Normal belief is professors, teachers, research students, they are the researchers. They are, but they are not the only researchers. Anyone who has combination of creativity and curiosity. Curiosity gives you questions. Creativity gives you the possible answers. So you need to see that what could be the different questions. So what you have to do, you have to learn basic science of physics. You need to apply that knowledge into some application. You need to see how to make that application much better. And by combination of curiosity and creativity, you could arrive in at a wonderful position. Now, as a student, you have got several skill sets like patience, you are a good thinker, you are creative, you are finding solutions to your challenges, you are multitasker, you can take an n number of assignment, you have self-control on yourself, you are responsible, you are collaborating, you are sharing responsibility between your friends and things. You are optimist. You are having a desire to do something, and you can communicate, and you are curious, you are accountable. So this is all you as a student. But as a professional researcher, you require all of these qualities, including curiosity, making observations, logics, creativity, objectivity, but you are also open to skepticism. Skepticism is one of the major factor we need to take care as a researchers. We are open for peer review. And we are always looking for targeted results. Like, for example, if you are doing a research to develop a product, you should know how to do it. So idea is you should make observation, you should have some questions, develop a hypothesis, do your experiment, analyze, and conclude to make new observations. So the journey as from student to professional researchers require skepticism, peer review, and targeted results. So if you can achieve that, that would be wonderful. What main thing as a researcher, you should know, does research make you happy? Because if you are not a happy soul, then you cannot do research, good quality research. Research, if I could say in simple language, it is looking for new information, new understanding, and new facts. It is also used to solve problem or increase available knowledge to a given subject. It tests theories and make observations. But most important is it makes us systematic, organized, and objectives. Now, meeting a current day researcher, especially a PhD student, is a pain these days because students are not very clear what they are doing, why they are doing. For example, if I meet a student, I ask him, what are you doing? The fellow will tell me something what he is working or she is working on. But why you are doing it, the fellow doesn't have an answer, except that sometime he will say, my guide has suggested. No, you are not a robot. You have to have your own questions. You should understand it very clearly. And I realize why people are doing PhD. There are several reasons. Many of them are laughable, but please don't laugh. They are very, very serious reasons. So some people are doing PhD just because they have passed master examination and they have nothing else to do at home. And they want to be away from home. They want to look busy. So they are doing PhD. So it's not a good reason to do PhD. Some people are looking for cheaper facility, especially in bigger cities like Delhi, Bombay, Bangalore, Hyderabad, where hostel comes at a very, very nominal price. You get bus passes and those things. People are doing PhD for that. No, again, it's not a good reason. Preparing for competitive examination is not bad, but blocking a seat for PhD for doing this is not good. Waiting for the golden time. Several people are waiting to either get a job or to get married, and until then they are doing PhD, which is again not a very, very good reason to do. Some people do it because they have qualified the test, and that is why they are doing it. These five are not good reasons. Good reasons are they are curious to generate new knowledge. They are planning to work on issues that bothers them, and they want to address the challenges being faced by the society, being faced by our own people. So these are three good reasons to do PhD. Now look at these two pictures. There is one water which is standing and it's gone stale, and second one is flowing water. Now suppose if I ask you which water you would like to drink, answer would be obviously the moving water. That is something you would, because other water has got stale. Same is with our education. The science is developing so fast that if you do not update yourself with time, you would be left behind. So it's a very, very dynamic orientation. Lot of new knowledge is being added into world of science, including physics. And then we need to know how to update ourselves. And I hope all of you might have seen the movie Three Idiot, where there is a dialogue. Even to come to the earth, we need to race. So is the research. In research, you need to be the first. If you are not the first, somebody else has reported the work, kind of work you are doing, then probably people will never acknowledge you. So you have to keep on doing research or the competitive. And if you don't do research, then you are out. For example, you may remember that Nokia was the brand leader of the mobile telephony, but they did not go for smart telephony and they were out. Similarly, if we say Kodak, the movie camera roll makers, they did not go for digital photography and they are out. So it means we need to constantly do the research, and if we are not doing research, we cannot survive in the market. And then it's not that once you have reached the zenith, you will survive for life. No, there are challenges everywhere. As I said a little ago about Nokia, Let me just repeat, because Nokia was once having 93% share of the global mobile market, but they lost it because they didn't do research. Even today, see mobile company, see car company, see any product, they are bringing in better version of their product number of times in a year because they want to constantly upgrade their products to sustain themselves in the market. And then there is uncertainty, like COVID. Suddenly we were home locked and we were not prepared for that. But what happened in COVID? If you are a student, then you will recollect. Overnight, we all became dependent on the digital platform. Our classroom was digital, our entertainment was digital, our shopping was entertainment, our consultation was digital. Everything became digital, and we started working in those environments. Also, COVID told us how to fight uncertainty. So, even though we did not have a prescribed medical protocol for that, doctors did, if I could use the word hit and trial, they were trying several things. They called it repurposing of drugs, repurposing of equipment, and they handled it. So we should also be prepared for uncontinuity. For me, research is only two things. Either we generate new knowledge or we develop new applications or make a new products. Now, one thing you must remember, whenever we are talking about research, first teacher is the nature. If we are working on any aspect of research, if we see how it exists in nature, it tells us much better. Just see this picture. This is a picture of the bullet photograph. Most striking thing is its nose of the engine, how it has been designed. And then see the picture of the aeroplane, which also has a nose very similar to that. And how does it comes? It comes from nature. So if we look at the principle of aerodynamics, very much you will learn in the physics class, you would realize how we could develop our products, how we could orient our products to be more efficient if we take care of principles from the nature. Now, at this level, when you are doing your master's or you are doing your PhD, the two things which you are always looking for. One is internship and one is fellowship. Of course, you will learn a lot in the institution you are registered for this course, but there is always a desire that you do some independent project work. And when you are doing the independent project work, it's called either internship or fellowship. Internship are primarily a part of your course, and they are encouraging you to do one independent project by yourselves. And once you are completed the course, then you are out of it. On the other hand, fellowship is creating your own question paper. Unlike other examination of the university, PhD is the only thing where you are not governed by any syllabus. Like up to your masters, even you were taught from out of within your syllabus, your question paper was within your syllabus. But when it comes to PhD, when it comes to research, you are setting your own goal, and your teacher, your guide, your mentor help you in designing your research questions and convert it into several smaller objectives or milestones so that you could achieve this thing. So I think you should remember how the two words are different. Internship you can do anywhere. So, for example, several central organizations like IITs, Central Universities, Indian Institute of Science, ICERs, triple ITs, and several other organizations are inviting students from other organizations to come and join them for this participation. Similarly, laboratories from CSIR, DRDO, DSD, DBT, they are also encouraging internship. Industry, of course, they are more interested in such work because then you would be exposed to the real problem being faced by the industries. And non-governmental organization, they are also asking a student to work with them. So depending upon nature of problem you have taken and depending upon what you have been suggested by your teachers, you could choose an internship. Remember, these internships are primarily in terms of finances three-way. They are either free, gratis, or you could be charged for it, or you could be paid for it. So normally charges are nominal. Payment is also nominal so that you can sustain yourself without additional expenses on the parents. And then there are fellowships. Now remember, fellowships are not jobs. Fellowships, so don't compare when you are doing fellowship with a colleague who have taken job and doing a regular employment. So they are two different things. Fellowships gives you a pleasure of creating new intellectual property. Jobs you are doing for your employer. So one of the first fellowship which we can talk about is JRF, SRF, RA. The most common way of getting them is to qualify a national level examination, which is conducted by UGC CSIR. But then it's not only UGC CSIR, several other agencies, including ISRO, including Atomic Energy, and several other agencies like DBT, uh, they are conducting these examinations and you should qualify. So basically, GRF is one who is a fresh researcher, SRF is one with 2 year research experience, and RA is one who has completed either PhD or a master in professional courses. Now, there are several doctoral fellowships. So I'll tell you now mostly about some of the fellowships which are very common in our part of country. So one is the AICT doctoral fellowship. So like you have qualified NET, you can also qualify for AICT doctoral fellowship. And the only thing is that you need to work here in AICT approved institutions. AICT also provide national doctoral fellowship. This is additional thing. And basically, this is for those fellows who are working as faculty. You know, in several colleges, especially private colleges, people are getting employed as a teacher after doing their MTech. So they can also go for this program under QIP. Department of Atomic Energy also provide doctoral fellowships, and they are more interested, as their name suggests, like atomic energy, in subjects closely alienated with them. So physics is, of course, part of it. Physical Research Laboratory in Ahmedabad, they are also having doctoral program, and they cover subjects related like astronomy, astrophysics, atomic, molecular, and optical physics, geosciences, planetary sciences, space exhibition, solar physics, space and atmospheric sciences, and theoretical physics. Then AICT Quality Improvement Program, it is given to the faculty, so they can also participate. And then you can also join Fulbright Nehru Doctoral Fellowships. Now, Fulbright Doctoral Nehru Fellowship means that you need to be registered in an Indian university, and for a period of 6 to 9 months, one could go to United States. Here, I must say, whenever we are talking about overseas doctoral fellowships, including Fulbright, main emphasis is on second and third year students because in first year we expect a student to formalize the research processes and also to close the research topics where fellow is going to work. But in second year and third year, this exposure could help him or help her in going forward. And we are not taking subsequent students because they are on the verge of submissions. So here, friends, for you, subjects like main physics, energy, materials, earth sciences could be of your interest. And then you should not look only as physics. You should look as application or interdisciplinary aspect of the research. Similarly, there is Einstein fellowships, and here they would like to work on combination of humanities, social sciences, and natural sciences, and how we could take it forward. There are several Max Planck institutions in Germany on different subjects, and they are also inviting researchers to work with them for the doctoral program. Uh, there is Fulbright Kalam Doctoral Fellowship, which is more on the climate aspects. Now, when we are talking about climate aspect, we are not talking only about climate, we are also talking about clean energy, energy transitions, how it will impact several other factors, financing, new technologies. So all those things which have any impact on climate are covered. And like the Fulbright Fellowship, here also Indian students need to be registered within India and they could go to US for 6 to 9 months. Companies like Google, they are also providing research fellowships. Of course, whenever a private company is providing full PhD fellowship, they are more interested in the subject which is dealt by them. And then there are several overseas universities which are providing research support, PhD support. And this is one where TOEFL or IELTS is not required. And sorry. And then there are several postdoctoral fellowships. So suppose if you have completed your PhD, lot of postdoctoral fellowships are available from different institutions, including CSIR, Atomic Energy, Biotechnology, Space, Department of Science and Technology, Council for Medical Research, Tribal Affairs Ministry, uh, ANRF and PDF, and then several IITs are also providing institutional postdoctoral fellowships. Besides Indian postdoctoral fellowship, there is a fellowship from Japan under the name Metsuami, which takes care of a lot of things and all subjects are welcome. Then we have got, Prime Fellowship, one of the most popular fellowship. And I'm sorry, date written here is last year, but it is just open. Anybody who has completed PhD could apply. Right now, this call is open. And then we have got even in Indian institutions, there are several departments which are offering postdoctoral fellowship established by the industry. So they are looking for cutting edge research in a given area. Postdoctoral fellowship with Fulbright, you can do, you could spend up to 2 year period in United States on this program. And then in Austria also, you could do postdoctoral fellowship for 2 years. If you are a mathematics or you are a theoretic physicist, you could apply for ISIM fellowship in Europe. Then there are programs of which India is member, like Human Frontier Science Program. But it does not mean that you should have a biology background to avail this fellowship. Anybody who has any impact on human subject, including a physicist, they could participate in this program. Marie Curie is one of the most popular and most demanding and most competitive fellowship to work in Europe, and one could participate there. Even Saudi Arabia, they are offering a good amount for postdoctoral fellowship, and one could participate in July. Besides that, we are in India these days, we are expecting a doctoral, postdoctoral, and even at master level to write about your own research in common man language. These days, research is getting very, very difficult. We are using hard terminology. We are unable to explain it to common man who are actually supporting this science. So we have started this program. This is just an encouragement to the young researchers to help them in understanding their own research in common man language. Science Academies of India, Indian National Science Academy, National Academy of Sciences, and Indian Association of Scientists, they are providing a program which is called Summer Fellowship. Here, you may be registered anywhere in India, but you can go up to 2 months to another institutions where you could do your research. the host institution should be other UGC accredited institutions. Lot of you would like to participate in international seminar symposium, and for that there are several agencies, including Anusandhan National Research Foundation, Biotechnology, ICMR, INSA, CSIR, AICT, INAE. So a lot of travel grants are available. There are other fellowships also. For example, Indo-German Science and Technology provides up to 6 months to work in German companies. Wiser program provide an opportunity to female researchers to have an Indo-German project. Nano program encourages researchers to do nanomaterials program. They can go anywhere in the world. IGSTC Raman Paid Fellowship is to encourage young researchers to develop research group and visit each other's institutions. And Raman Chapel program provides an opportunity to France to go there and work up to 6 months. There are other events, for example, BRICS Young Scientist Meeting, where each year, depending upon the host country, they announce themes and we invite application. Frontier of Science and Frontier of Engineering is very, very interesting. Frontier of Science, basically, we're looking for young achievers in different disciplines like physics, chemistry, mathematics, biology, geology. And then we ask them to have some interdisciplinary questions which they could try to answer. Khurana and EMBO, they are both biological program, so we could ignore it. But then there are some few other overseas fellowship like Humboldt from Germany, Newton from UK, Erasmus from European Union, which are very, very important, very prestigious and very competitive. Even in smaller countries like Hungary, Poland, Austria, Japan, New Zealand, Singapore, they are also offering fellowship to our researchers. And Indian agencies like Atomic Energy, Biotechnology, Earth Sciences, they are also offering fellowships. So let me just talk about Lindau Fellowship, which is a meeting with Nobel laureate. And here we are taking our MSc, MTech, and PhD student for meeting with Nobel laureates. So this is normally a 2 week activity in Germany, and it happens in cyclic order: 1 year physics, 1 year chemistry, 1 year biology and medicine. So depending upon the subject on which Nobel laureates are being invited, we take our students. So 2 weeks course, 1 week you listen to the lecture by the Nobel laureate, and remaining second week you are interacting with them. Similarly, on that level, we are inviting Asian Science Camp, where we are interacting with a lot of young researchers from Asian countries. India has bilateral arrangement with nearly 80 countries, and we are encouraging young researchers to be part of these projects, which could expose them for 3 to 6 months. Frontier of Science Engineering, as I said, it's an interdisciplinary subject meeting. We have program during PhD, student could go to UK and Japan, and they could do it. Now, coming to some of the major physics program which we are dealing with, one, there are a lot of things. Idea is these facilities, as I have written in the blue on the right hand side, these are in different part of the world, and they are very expensive facilities, and we are doing some quality research over there. For example, if we talk about CERN, European Center for Nuclear Research in Geneva, so India is participating in CMS and LIS program of the CERN. And currently 14 groups are participating in CMS and 15 groups are participating in LIS. And then we have got 29 research groups which are using various grids of and CMS and LIS. So our researchers are primarily involved in physics analysis and also in data. Then if we could talk about the NOVA experiment in Fermilab. So 9 research groups are participating in neutrino experiment, and new groups are being included each year. We have a synchrotron, Electra in Italy, and again there is a dedicated beamline for Indian experiments which is being used, and a lot of these things like Express is a beamline, and high pressure diffraction experiments at ambient temperature are being performed. This is open to users. People could come and participate, especially in areas like condensed matter physics, material science, chemistry, geophysics, and mineralogy. Then we have set up locally also 20 keV ion beam facility in Kurukshetra for research on material sciences. We are also participating in a German project called FAIR, and here we are looking for participation in a big way. Uh, Several power converter vacuum chambers India has provided to the FAIR. Then we are planning to set up a 30-meter telescope in Hawaii Island, and India is one of the founder member, and we are providing both equipment and financial contributions for its orientation. India would be hosting the third center of LIGO. LIGO is a project, large interferometry gravitometer observatory, which started from United States, and Australia is the second center, and India would be third center. So we have identified the place called Hingoli in Maharashtra, and this would be a facility for R&D and prototyping production of high-tech equipments. We are also participating in a square kilometer array. This is a project in Australia and South Africa. We are one of the founder member. This is in construction phase, and a lot of things are being worked out. We are also setting up a national large solar telescope in Ladakh. And this project is currently under construction. And if it comes up, it would be a very large solar telescope within the country. Friends, research can give us a lot of things. It is a tool for building knowledge and facilitate learning. It also provides us access to the latest information, means to understand issues and increase public awareness, help us in planning our business, to disapprove lies and support truth, to find God and seize opportunities. But most importantly, as I said earlier, it promotes love and confidence in reading, writing, analyzing, and sharing valuable information. Now, when we look for the career options, when you have completed your PhD, of course, one of the easiest thing is that you could go for academic position. You could do policy research. For example, our Prime Minister is saying how India would be in 2047 when we achieve 100 years of our independence. So that's a policy thing. So we need to plan how physics will go, how various subjects closely associated with physics could go. We could work as a research scientist or a research or engineer in any industry who is aiming to develop new products or improving existing products. Quality assurance is just reversal of research scientists, and they are trying to ensure that the quality associated with the brand name is maintained. Then there are researchers who are working in the market, in the field, and they are trying to take experience from the user. That is how a lot of car companies and mobile companies are coming up with their newer model. You could work as a project manager in academic organizations, scientific organizations. Such positions do exist where they need people who could manage different projects. Technology assessment manager position. So this is how you need to understand how a technology could survive in the market and what is the future, what is the commercial value, and those kind of things. You could work like a health economist. You could work as an editor to a journal. You could be a professional. You could be a social science communicator. You know, as I said a little ago, that we have put science in such a difficult words that common man doesn't understand. So we need people who could communicate science. You could be a government officer like I was, and I was into the science facilitations. You could create your own startup. So what I'm trying to say that there is no end to the career options. So don't feel that after doing PhD you are just locked in the academic world, but there are a lot of options which you could think of. So with this, friends, I would like to close, and I'm available on social media. You can follow me. And if there are some immediate questions, I would be happy to take them. Thank you.
Thank you, sir. Now, if anyone have questions,
Hello.
Yeah, I'll request participants to raise their hand electronically so that Raman could invite one by one.